how you can build intelligent apps faster with Azure SQL Database. You know, technology is shaping how businesses plan for innovation and growth within their markets. It creates new opportunities through digital transformation. And we see companies responding by creating different types of digital strategies across 4 core areas. You know, they're looking at new ways to engage their customers, to empower their employees, to optimize their operations, and transform their products. And the focus of our discussion today is on how to transform your apps to delight your customers, both internal and external, using built-in intelligent features that can do things like spot trends or react to unusual events, predict outcomes, or even recommend choices. And on the IT side, to help you optimize the performance and security of your operation. You know, most everyday apps from consumer to enterprise can deliver greater customer or business benefit by learning from user behavior and other signals and delivering that value quickly and consistently. While today's focus is on building intelligent apps, these capabilities can also enable the right mix of operational efficiencies and business enablement to drive growth throughout the organization. You know, many digital transformations start with IT optimization, basically helping IT do more with existing or even fewer resources. And IT orgs are always looking at ways to optimize how they can maintain and use the data that fuels their operations. And oftentimes that begins is the first step towards a digital transformation. And so with IT optimization as a key to driving that transformation, it ultimately introduces some new priorities that IT needs to consider, such as how can they eliminate the time that they spend managing long tail of apps? How can they free up resources to drive this transformation? And ultimately, probably a subject of another discussion, how can they migrate those critical apps to the cloud? So how can these orgs best address priorities on this transformation journey? You know, the answer to that is Azure SQL Database. It's a fully managed, relational, intelligent database as a service that provides the best and most economical cloud destination for your SQL Server data. A SQL Database uses the same engine as SQL Server, which means it's high performance, it's reliable, it's secure, and you can use it to build data-driven apps and websites in the programming language of your choice without needing to manage the infrastructure. But in addition to the benefits that you'll realize with a PaaS solution, SQL Database also provides key benefits in some specific areas. And today we're going to focus on the built-in intelligence that helps you dramatically reduce the costs of running and managing databases and also help you maximize the performance and security of the app. So how do we deliver on that? We do that by running millions of customer workloads around the clock. SQL Database collects and processes a massive amount of telemetry data, and while also respecting customer privacy behind the scenes. And we run various algorithms that are constantly evaluating the telemetry data so that the service can learn and adapt with your app. And based on this analysis, the service comes up with performance-improving recommendations tailored to your specific workloads. You know, Microsoft was the first to market with an intelligent database service, Azure SQL Database. Starting in early 2016, we began delivering this machine learning value built directly into the service. And over the last year or so, we've delivered many intelligent capabilities to include automatic performance monitoring and tuning, adaptive query processing, intelligent threat detection. And these capabilities help you dramatically reduce the cost of running and managing databases while also maximizing the performance and security of the app. Today we'd like to introduce to you many of these features, and we're going to do that through a SaaS app. So let's see some of these features in action. I'm going to hand it over to Elaine, who's going to demonstrate many of these intelligent capabilities through a SaaS app called Wingtip. This is a web app that's used by small venues that host events, and at the end of the day, they just want to sell tickets. But each venue needs to have a customized experience backed by their own database. And I'm going to hand it over to Elaine to show how we do that.
Hi, thanks, Eric. So yes, as Eric pointed out, we're going to be looking today at an application called the Wingtips application, which is essentially a ticketing platform. It will allow a single SaaS developer to create a platform on which multiple venues can create sort of a front end for where they can sell tickets to customers. So we have a very simple web app here that is running on top of multiple SQL databases, and we'll dive into that architecture soon. But the point, the whole exercise of this demo is to show you that you can build applications that are not only multi-tenanted, but they also allow you to have workloads that are geo-distributed. So the same architecture that we'll be discussing here today can be applied for both scenarios. So if you had a customer base that was, that sort of had the follow the sun architecture that we refer to, that worked in multiple different time zones, to ensure that applications performed at their peak all the time, you could use very similar deployment patterns as what we're going to look at now to ensure that the database is always as close to the applications and thus giving a better performance to users. So the Wingtip platform very simply allows you to provision different venues within the application, and you can then have all of these venues, or enable all of these venues to sell tickets through this application. So in the back end, if we look at what it involves in Azure, it's actually quite a simple deployment that we've got here. So essentially we have what is the catalogs database, which is the underlying database that allows the application to function and gives it all its functionality, as well as allowing users to log in through the catalogs database and thus land up on the correct venue's web page. Attached to that, we have a SQL database elastic pool, which is specifically around the tenants database. So every time a new venue is added, a new SQL database is created within this elastic pool, because as we see with certain workloads, they are not always consistent. Some events and some venues would have higher requirements for performance, whereas others might not in sort of off seasons and things like that. So if we dive a little further down into the application itself, apart from the SQL databases that we have here, we've also got a traffic manager, which essentially directs the traffic for spikes in workload, so that you have an even and distributed workload, and you can have far more predictability on the performance of the underlying databases as and when you need it. So very simply, that is how we've deployed it to Azure. This entire deployment is available. The link is in these slides, and you can have a look at how we've done this and apply it to your own applications to essentially create multi-tenanted or geo-distributed applications, either for internal line of business applications or for external new SaaS projects that you're working on. So going straight into the code, we've got PowerShell here, and we've actually generated what is a sort of a load of tickets that are being sold. This PowerShell script, all it essentially is doing is it's inserting rows into the database, and it simulates a workload. And we've specifically designed this PowerShell script to generate a random workload so that you have spikes in traffic, and it is not a sort of overall consistent workload that's flowing in. What I'm going to show you now is if we go back to the home page for Wingtips, you'll see we currently have 3 venues available, that being the Contosa Concert Hall, the Dogwood Dojo, and the Fabricam Jazz Club. Now, very simply, I'll show you how we can create an additional venue, or in this case, it would be an additional tenant, using something as easy as PowerShell. Now, from a programmatic standpoint, all of these can be embedded directly into the application so that it would be a automated function in the back end. We're going to run this PowerShell script, and we will then see that Red Maple Racing will have been created as an additional database, as well as have all the pre-required tables generated inside it for us to continue or for us to service this venue. So we're just waiting for this database to deploy, and while we do that, we're quickly going to come back to the Wingtips application, and you should see as soon as that database comes online that we will now have an additional venue that'll come up. Still hasn't come up. We'll keep an eye on it. But if you come here to to the Azure portal, you should see that the new databases will start being created as soon as they come up. Redwood Racing, they seem to be taking a bit of time today. But we'll move on anyways. We'll come back to that point. But it's as simple as deploying this PowerShell script to create an additional tenant for an additional venue that you can service tickets to. So apart from that, we're going to look at what are the advantages of running a database or running a SaaS application in this configuration that we have here. The biggest advantages you're going to have is you're going to be able to distribute your workload quite evenly, and you're going to ensure that there's optimal performance in all your databases. After that, we'll look at how SQL Database enables you to have more intelligent optimization on top of your database. So if we look at the database pool that we've created here for our tenants, you can see that at a bird's eye view, you can quite easily monitor the performance of each database. You can keep track of workloads overall, as well as you can see the individual databases and their workloads. You'll see there that Red Maple Racing has now been created. So if we go back to the Wingtips application and we refresh here, you'll see that we've now got Red Maple Racing that has come up. So that's how easy it can be to have an application that self-provisions in the backend. That is a standalone database that is part of an elastic pool in the backend, so it will control how it scales as the workload demands. So if we had to go in here, you would see you have a brand new page for a new customer, which is now the Red Maple Racing way, and they have no events registered at the moment. So if we switch over now to Visual Studios and we actually go look at the structure of each of those databases, as I said, there are two very specific database services that are running. There is the tenant level service, which has a single database. You'll see there we have Contosa, Dogwood, and Fabricam. If we refresh that list, you will see that Red Maple will come up now. And each venue has its own database that is running. That way you get isolation of workloads, so that if one venue all of a sudden has a lot of traffic, it will not affect the performance on the other databases. But we also have what is the master database, which is essentially this catalogs database, which controls how that front end runs and all the data that is populated there. So we're going to dive more specifically into the Contosa Concert Hall. And if we look, for example, at the query for venues, let me just zoom in here. You will see that the venue here, in this case, as we are querying against a single database, is the Contosa Concert Hall. So if we then go and run it against venues, which is a view that allows us to see multiple venues, you will see that we can very easily, from a high level, we can show you what's going on at all the different venues that we have. Right? So here we have a list of all the events that are currently running at the Contosa Concert Hall, and then we can sort of view the projects by their venue ID. Right? So this is looking at a single venue. But now if you as the SaaS, sort of as the developer for a SaaS application, wanted to have more insights and add more intelligence into your database, you would need to be able to do queries across multiple of these databases at the same time and run some type of analytics on top of that. So if we go and we change our context now to the tenant catalog and we rerun a query here to see all the tenants, you'll see it's going to bring up the 4 tenants that we're expecting, except for the fact that we're in the wrong context. Let's just try that again. I see there's a mistake in the code. I'm just going to take that out. If we run this query now, you'll see we have our 4 venues. So what we basically land up doing is we created what is called the analytics database, which sits inside the catalog. Now from there you can create a view that spans across all of the tenant databases. This will give you the ability to do analytics for all of the tenants that live within the SaaS application. So you'll see here is the create table statement. So this specifically is an external table that is using Elastic Query to reference all the databases that sit inside of the tenant's Elastic pool. And we have sharded this on the venue ID. So this is a single view that has the ability to look across all of the venues. And the big advantage of doing something like this is that it gives us the ability to essentially run queries that look, wrong button. We can create queries that will look across multiple tenants at the same time. You'll see there we have all the tenants, but now instead of us pulling it from the master catalog, we're actually pulling this from that material, from that view that is sitting across all of the databases. What if you wanted to know something like what are the different venue types that you have? We can run that query quite easily, and you'll see it comes up with sort of what the different venue types are, what the different event types that they generally host at those venues are. Now we get into a bit more of the analytics portion of it. So if we want to see, for example, how many tickets were sold across all of our venues, you can very easily execute a query like that, and you can see by day how many tickets were sold for every single one of the venues, not just a single venue. So the reason why this is an extremely important function is because if we include the execution plan, you will be able to see on this query that what is actually happening in the back end here is that the query is actually being distributed to the individual databases and pushing the workload out onto those databases. That way you're not centralizing the data in a single place. You don't have to reduplicate your database, and you can take advantage of the compute that you're already paying for on the databases that you provision per tenant. My Visual Studio seems to be stuck at the moment. As soon as it comes back, oh dear, we've gone to a white screen. Let's see if we relaunch it quickly. I'll come back to these queries. I'm going to hand back to Eric while I reload my Visual Studios quickly, and then I'll show you how these sort of analytics functions can work across multiple of these databases at the same time, and how you can see from the execution plan that the actual compute for the query is being pushed down into the individual databases and not being centralized up in the analytics database.
All right, thank you, Elaine. And so while we're waiting for the app to catch up with us, I'd like to touch a little bit on the intelligent capabilities that can optimize the security and performance of your apps. And then we'll wrap up the session with showing you how you can take advantage of those features. Let's start with threat detection. This is a relatively new set of capabilities that make it very simple to address potential threats to the database without the need to be a security expert or manage advanced security monitoring systems. You know, SQL threat detection leverages SQL database auditing to constantly monitor SQL databases for potentially malicious attempts to access sensitive data. You know, threat detection provides an entirely new layer of security, enabling you to detect and respond to potential threats as they occur by giving you real-time security alerts on activities that really just don't seem right, or they're really out of the norm. They're anomalous. So you get to receive real-time alerts based upon suspicious database activities that we detect, potential vulnerabilities, even SQL injection attacks. and by looking at anomalous database access patterns. And SQL threat detection alerts provide details of that suspicious activity and also recommend action on how to investigate and mitigate that threat. And so you can explore these suspicious events to ultimately determine if the event results from an attempt to access or breach or exploit the data in any way in your database. And we touched on a little bit earlier in the presentation around the resources that IT has less and less of, and they can use some help in being able to optimize the performance of the database and ultimately optimize the performance of the app. And so with that, we've got a suite of intelligent capabilities within SQL Database that effectively enable self-tuning performance. We've got SQL Database provides a detailed insight into the queries that you ultimately need to monitor. It learns about your database patterns, and it enables you to really adapt your database schema to your workload, effectively providing performance tuning recommendations where you can review the tuning actions and even apply these recommendations. But we also recognize that constantly monitoring your databases can be a really hard and a tedious task, quite honestly, especially when you're dealing with many, many databases. And so Intelligent Insights really does this job for you by automatically monitoring database performance at scale, and it informs you of any performance degradation issues and identifies the root cause of the issues, but it doesn't stop there. It actually provides performance improvement recommendations when it's possible. And so managing a huge number of databases might be impossible to do efficiently, even with all the different tools and reports that SQL Database and the Azure portal provide. But instead of monitoring and tuning your database manually, you might consider delegating some of the monitoring and tuning actions to SQL Database using automatic tuning. SQL Database automatically applies recommendations, and it tests and it verifies each of the tuning actions to ensure that the performance keeps improving. And so in this way, SQL Database automatically adapts to your workload in a controlled and a safe way. Automatic tuning means that the performance of your database is carefully monitored, and it's compared before and after every tuning action. And if the performance doesn't improve, the tuning action is actually reverted. We touched on the Wingtip SaaS app, and many of our partners running multi-tenant SaaS apps on top of SQL Database are relying on this automatic performance tuning to make sure their apps always have stable and very predictable performance. And for them, this feature tremendously reduces the risk of having a performance incident in the middle of the night. In addition, since part of their customer base also uses SQL Server, they're using the same type of indexing recommendations provided by SQL Database to help their SQL Server customers. And finally, I'd like to touch on adaptive query processing. We're also adding this new family of features to SQL Database. And this includes things like interleaved execution on multi-statement table-valued functions, batch mode memory grant feedback, and batch mode adaptive joins. And each of these adaptive query processing features applies a similar learn and adapt technique, helping further address the performance issues related to historically intractable optimization problems. What I'd like to do now is hand it back to Elaine.
Thank you, Eric. So let's quickly go back to those the queries that I was trying to show you earlier, and the specific functionality that we were trying to display with these queries. There we go. So you'll see here we're now inside the catalogs database, which, if you remember, is sort of the management database that sits on top of all the different tenants. Inside that, we've created what is the ad hoc analytics database. And from here, we've created multiple external tables that actually point out towards the individual tenant databases that we have for the 4 different venues that we created earlier. So if we look very easily, and how we can demonstrate that is if I execute a very simple query like just selecting the venue name from the sort of abstracted view, which is venues, which looks out on top of all of the individual tenant databases, you'll see it brings back the 4 venues that we're expecting, which is obviously the Raceway, the Jazz Club, the Concert Hall, and the Dojo. But if we look at the execution plan, and this is sort of where a lot of the benefits are lying with going for these type of deployments, you'll see that that 100% of the effort to complete this query was done remotely. So ultimately what SQL has done is it has taken that query and it has pushed the computational effort of completing that query down into the individual tenant databases. So as I said earlier around the geo-distributed patterns that follow a very similar type of architecture to this, you could very easily have an application that is sharded across multiple databases for a performance improvement as well. So that's a very simple query that just looks at the venue names. If we run something that is slightly more complex than that, you'll see in the query plan that we get a very similar expected output, whereby you get the remote query that is actually executing the bulk of the workload. So this ad hoc analytics database that we have here is not actually doing any of the work other than potentially doing the last little bit of either the joins or the aggregations that are required to complete the query. So let's look at a bit more complex example where we want to see, for example, how many tickets were sold across each venue per date. So you'll see this query completed within less than a second, and purely because the query is being computed on the individual tenant nodes. So if we look at the execution plan again, you'll see that the bulk of the effort is lying on those individual tenants. So we can then do a more complex one, and we can look at revenue, for example. And here you've got sort of the total revenue for the number of tickets per venue that you have. And there you have the sort of the sharded name for each of those venues. And then the last one that we will look at here will just gets a little more complex in the sense that we're now looking at the top 10 grossing events across all the venues. You will see here that this A Night at the Opera from the Contosa Choir was actually the top selling event with 1,200 tickets. And again, if we look at that execution plan, what's critical here is that you'll see that the bulk of the computational effort is not actually sitting in the database context that we're executing the query from. It's all being pushed down into the individual tenants. So if you were building a SaaS app that had sort of a cross or a chargeback model where you were actually charging customers for all of the work that you were doing on their behalf, this is an ideal way to keep track of sort of how much, or at least to isolate that computation inside the individual tenants. And that sort of covers the basis of the WingTip app. What we will look at now is some of the features that Eric was talking about earlier. And these are the built-in intelligence features that live within SQL Database. I've stopped sharing. Sorry. Sorry, the sharing dropped there. So we're going to look at the performance characteristics as well as those auto-tuning functions that Eric was talking about. So we're here on the Azure portal, and I've got this SQL database which is called SiteEE, and it runs a variable workload. You'll see I actually started off the workload this morning at about 7 a.m. And it kind of runs and has a very non-linear sort of way of executing. It's a very random workload that's running. So you can, from this high-level view, you can very easily see which are your long-running queries and then potentially address those. Moreover than that, you can come and look at the recommendations. So in the back end, what's happening here is that from the telemetry and understanding sort of SQL database quite well, what we have been able to do is build an engine that makes recommendations that will increase the performance on top of your databases. So if you look specifically here at this recommendation that we have, it's essentially saying that if you turn off parameterized queries, you can have up to a 23% CPU saving. And very simply from here, you can view the script that'll allow you to do that, and you can then take that script and execute it against your database, and you will get that estimated 23% improvement in CPU utilization. And this is just one of the many features that we have around the intelligent database that help you sort of build applications better instead of having to worry about the database and how to tune the database the whole time. Some of the other recommendations that we, for example, have are the schema-related ones. But moreover than that, if we look specifically at the auto-tuning characteristics, you will see that we have the ability here to turn on sort of the auto-creation of indexes, to drop indexes, and all of these features are built to make the database run as optimally as possible so that it is something you have to worry less about. If you think of this in the context of the Wingtips app, whereby instead of having just 4 tenants, you had 1,000 tenants, managing those 1,000 databases becomes quite a lot of effort to do that. So with these type of features, we're enabling you to make those changes and have optimal performance out of the database without someone having to manually monitor every single database. These performance metrics also now have the ability to integrate into OMS, so you could have a scenario whereby your entire sort of IT infrastructure is being managed from the database level through to the infrastructure level through the OMS portals, and your DBAs and your infrastructure teams could very easily manage the entire state from one place without having to sort of jump between databases the whole time and have various different types of monitoring tools involved. The very last one that we will look at is the vulnerability assessment. So this is still a feature that is in preview at the moment, but ultimately what this does is it gives recommendations around the security of an environment. So again, if you think in the context of something like the Wingtips app, where you potentially have hundreds or thousands of users that are accessing this all the time, security becomes extremely important, especially when you're talking about money and credit cards and these kind of things. So with vulnerability assessment, we give you a report that'll tell you where the risks lie within your database. So for the specific example, it is essentially just recommending that we shouldn't be using the DBO execution context for some of the queries that we run. So I mean, that in general from an app dev standpoint is quite a good recommendation. You should always change the default schemas when you have multiple people inside a database. And that kind of covers the bulk of the intelligent aspects that live within Azure SQL Database that have been built in to make the use of the database an easier process for developers and DBAs alike. All right, and then let me just jump back on to our slides. Where are we? Yes, so as I was saying, right, the biggest sort of advantages that you're going to get out of running your applications on top of Azure SQL Database, there are multiple ones of them. The intelligent database aspect is something that we've been doing for the last 2 years. I mean, we have millions of databases that sit within Azure, and it is in everyone's best interest that they always run optimally. From a resource usage perspective through to a total cost of ownership for those things. So what we've tried to do is we've tried to build the pools as well as the singleton databases and with managed instances coming with that sort of in mind, and that you want to optimize your investment in these products, but at the same time you don't necessarily want to introduce new risks into your company, and you also want to increase how fast you can go to market with these new products. And that's very critical when it comes to sort of fast-moving SaaS development landscapes. At the end. And then just lastly, the entire Wingtips app, including all of the sort of the learning steps that you can do, is available on the GitHub repository. You can go and download those. You can run through it yourself. I would recommend looking at that architecture and thinking about how you can take existing legacy applications or even new applications that you're developing at your company, and how you can build them to be sort of future-proof, so resilient to an increasing customer base, or even just from a disaster recovery standpoint. And then obviously there's the immersion labs that you can go do, which look at the modernizing line of business. And then obviously the very last one is just a informational web page on all the intelligent services built into Azure SQL Database.
Okay, so we have a little bit of